Hello everyone. The wait is over. The QA Touch FutureTest 2025 is live now. Welcome to QA Touch FutureTest 2025 on a very special day, Global Testers Day. Welcome Sparsh Kesari from LambdaTest. Will kick things off with build your own AI testing agent, showing us how to craft intelligent testing tools that leverage AI for powerful results. Welcome. How are you?
Thank you so much, Edmund. Yes, I'm doing very well. Uh, First of all, happy Testers Day to everyone of all of you, all the curious minds out there, all the quality engineers, all the guardians of quality of product. Happy Testers Day. We wish that this was a global holiday, but we can make what we have. So yeah.
Yeah,
Uh,
100%. And the stage is now in your hand. Like you can take over.
sure. Thank you so much, Edmund. Let me share my screen. I hope my screen is visible. Hi everyone. Welcome to this exciting session on how to build your own testing AI testing agent. I'm thrilled to have all of you here today, and we will dive into what is the future of testing with AI and agents. As Edmund said, and uh, AI will not replace testers. AI will augment testers, and it will give testers a special superpower. So we will learn about how we can what. So we'll learn about what is AI agent and how can you use it into your day-to-day testing workflows. So now let's get started and see how we can build more smarter and more efficient agents together. And just before we start, just a introduction. I'm Sparsh Kesari. I work as a senior developer relations engineer at LambdaTest, where I get to work closely with and for the testing community. And my team at LambdaTest is building an AI native end-to-end test engineering platform that we will get to see later in today's event. But for now, so if you have any chat, if you want to chat, or if you want to contribute to testing community, or if you want to know more about LambdaTest or community, please feel free to scan my QR code and would love to connect with you all. Uh, so in today's session, here's what we'll learn together. We'll start with what AI agents actually are, setting up the foundation and understanding about agents and autonomy. Then we'll move on to the architecture of agent. We will look into some of the agentic frameworks and how they are shaping the ecosystem. After that, we will also deep dive into MCP or Model Context Protocol, uh, which is a powerful way to connect AI agents and tools and systems. And finally, we will end the session with a short demo where I will show you how you can build or even customize your own AI testing agent according to your needs. So before we get started, so let's begin with a question. What exactly are AI agents? At their core, AI agents are the system that can autonomously perform tasks. Unlike a traditional AI agent, a, uh, unlike a traditional AI model that just gives you one-time response, an agent can actually reason step by step, plan workflows, and take actions using tools that is available to it. Now, these actions are not limited to generating tests. Agents can handle things like decision making, problem solving, interacting with external systems, and automating process. That's why now you see AI agents everywhere, from software testing to automation to code generation and even conversational assistants. So, what makes this possible? At its core, most agents are just LLM models. The LLM acts as the brain, but the real magic happens when you give the brain the ability to call tools, fetch real time data, break down big goals into subtasks, and execute them. This is where agents go beyond static models and become truly useful. Another key piece is learning and memory. Agents can store past interactions and adapt to user preferences over time. This feedback loops allows them to test, get smarter, and more personalized when you start using them. So, in short, AI agents just do not respond. They reason, they plan, act, and learn. And that's exactly what makes them a game changer for future of testing, automation, and the world. Now, let's deep dive into the autonomy of AI agent. AI agents are complex systems that are composed of basically five main key elements that work together to enable an autonomous task completion. The first is LLM, the brain. At its core, every AI agent is an LLM model. This serves as a brain of the agent, providing fundamental intelligence and language understanding capabilities. The LLM allows the agent to process, generate human-like tests, understand context, and make decisions based on vast amount of training data. Second comes the planning. Planning basically means dividing objectives into smaller tasks. One of the critical abilities of AI agent is the capacity to plan. This component allows the agent to break down complex objectives into series of manageable tasks like analyze given objective, identify necessary steps to achieve goals, prioritize these steps in a logical, sequential manner, adapt the plan as a new information becomes available. The third part is action, basically use of tools. The action component is where the AI agent interacts with its environment to accomplish tasks like uh, tools or APIs. We can perform tasks like performing web searches, executing code, accessing databases, and interacting with software systems. The fourth comes the profile. The profile describes the agent behavior. The profile of an AI agent defines its behavior, personality, specific capabilities, and it includes uh, agent's role or specification, tone or communication style. We can also add ethical guidelines and constraints to it. There are specific knowledge domains or areas of expertise. The profile enables the agent's behavior enables that it ensures that the agent response and the actions are consistent and appropriate for the intended purpose. And at last, the memory, the most important part of an AI agent. This restores and recalls the past interactions. The memory component allows AI agent to store and recall informations from the past interactions. This is crucial for maintaining the context of ongoing conversations, learning from previous experiences, performing and improving performance over time. Providing personalized responses based on user history, memory can be short term or long term as well. So, so you might have also tried LLMs in your past. So there is a vast difference between how traditional LLMs process things and how agentic process are processing things. The traditional LLMs follow a predefined path. For example, we have a query. Uh, a LLM will perform steps into a linear chain of reasoning. It will start with step one, and it might spread out to step two to step n until it gets the final response. LLM then crafts the information by analyzing the information that it gets from processing all the steps from 1 to n. The important thing is that everything happens inside the model and the flow is fixed and sequential. Thinking of it like walking down a straight road, the model doesn't pause you to bring outside help. It just reasons step by step until it reaches the destination. And that's where you might also have seen different types of hallucinations because it follows a probabilistic pattern recognition in the backend, and it gives you a response even if it doesn't get the correct response. Now, with agentic processes, it changed the whole scenario out there. Now, agentic processes don't just follow a single predefined path. Instead, the LLM first reasons about the problem, almost like stopping at the crossroad and deciding what the best route forward. How should I handle this step? For example, we have a query, and The LLM will then reason and understand what steps and how to distribute this particular problem by dividing into sub problems, how to distribute it into all the available agents that are out there. Then it delegates. Agent 1 should handle the first part, agent 2 should handle something, and agent 3 might be called only if it's needed. This is the act part of the agentic process. The LLM then keeps analyzing the results on the way. That's the reasoning part of the agentic process. And it adjusts the part dynamically based on the response that it gets. So there is no rigid script. There is a reason, act, and reason loop where the model can pivot, backtrack, and branch out as required. So basically, here the LLM is thinking what should be the next step and how should we solve this problem. Now, also let's see a bit of the thinking architecture of AI agent frameworks. There is there isn't one single standard architecture for building AI agents. Instead, there are different paradigms for solving multi-step problems. On your left, you will see a React model framework. This is basically reasoning with action and observation. Here, the task is wrapped inside a context and exemplars before being passed to the LLMs. Then the LLMs generates a thought and action. Then it pauses for observations from tools. And then it continues to reiterate this process until it gets a response. The observation is added back to the history and the loop continues. The TAO model, or the think, act, and observe model, it will reiterate the loop until the user gets the desired result. The challenge here with React framework is that uh, here is redundancy, and since the same context get refeeded in the loop, the process might get elongated. Like it might not be needed that much, but it get reiterated that much that we can call it redundant as well. On the right, we will see a Revu framework that is basically reasoning without observation. Instead of looping, a planner generates a structured plan. The worker executes the plan by retrieving evidences from the tools. The worker then executes the plan by retrieving the evidences from the tool. And then the both plan and evidences are combined with a task and fed to a solver, which produces a final solution. This avoids the constant repetition but shifts the complexity into planning and coordination. So the key takeaway from this is that agent frameworks differ how they balance reasoning, action, and observation, and that the choice affects efficiency, scalability, and how they handle the complex task. So if you are building a AI agent, you might look into these frameworks as well. So uh, now before we jump into model context protocol or MCP, now let's understand what the problem it solves. So basically, the challenge is LLMs or large language models are incredibly powerful, but they are also isolated. They need tools like APIs, databases, or files to interact with the real world. Now, the challenge here is called the N into M nightmare. For example, we have built a tool, a system where we have multiple AI models. Like we have Claude, we have ChatGPT, we have Gemini. One is using for chat, one is for image generation, and another is for analytics. And now we have other five tools like an API. It could be an automation script like Playwright, or it could be a CRM, or it could be a cloud storage soft service, and so on, which means that we need to build 3 times 5 or 15 separate integrations. Because, for example, Claude might give the response in a different schema, and while Playwright or an automation or an API might require data in a specific schema to process it. But what happens is that we have to build an translation layer between them. But what happened if in some days the AI agent or the AI model changes the output schema? All the work that we have done is lost. This creates a big problem. Developers are overwhelmed with the complexity and different APIs. They were constantly rebuilding stuff that they have already built, because the AI, the models or the schema that got changed. This process slowed them down. Teams were reinventing the solutions, and business get logged into specific vendors because the tools are tied to particular models. This tooling chaos hold back the full potential of AI, and we needed something to fix it. So very recently, uh, Anthropic came out with a MCP, or Model Context Protocol. This is a protocol. It's not a product. Like, think of it as an HTTP for web. Think like HTTP for web, but AI for MCP is for AI tools. Uh, MCP is an open standard, which means that it is a universal language which lets AI models communicate with external tools. So basically, understand that, like if you can see in the diagram, we have a host with MCP client, which have different types of MCP server 1, MCP server 2, MCP server 3, which are communicating with their different types of data. It could be a local data source, it could be one could be a code generation source, and third could be an API or a remote service. So they require input in a specific format, but the models will be giving the response in a specific format. So AI here bridges this gap. So they with the help of MCP, they created a uniform standardized layer where all the AI and the tools out there can communicate into a two-way system. So whatever the local system or the database or any tool that we are connecting can talk directly to the AI model, and as well as the AI model can talk back to the AI tool in a simple non we do not have to create anything for that. So this solved a lot big problems that we are facing out there. So the core idea is simple. Instead of creating custom integrations for every model tool pair, we just teach the model to speak MCP once, and each tool speak MCP once. So 3 models and 5 tools, you only need 8 integrations instead of 15. So you can also think MCP like an USB-C port for AI tools, a standard connector that connects and works across everything, simplifying development and making AI more accessible. So what so like in simpler terms, what did MCP introduce new? So MCP introduced a transport layer, just like a JSON RPC file, which is then followed by all clients and all servers to exchange data. And this happens in a very standardized way. This means that every tool, every model doesn't have to reinvent their own way to communicate. Instead, they are using a common format for request and responses. So now let's see AI in action. So for this, I have a simple so this is my VS Code, where I have installed a Playwright MCP, which is a model context protocol server that gives the client that is out there the browser automation capabilities of Playwright. So like you can go to the extensions, and you can find Playwright MCP, MCP servers down below. You can just click on you can also click on start server, and this will start the MCP server there. So the MCP server are not limited to just Playwright. Now MCP servers are built for all the languages and tools that are out there. This protocol is open and flexible, so any model or tool that follows it can communicate with the building the custom integration. For the client side, I have a simple VS Code IDE, and I have combined this with GitHub Copilot. This allows me to work as an AI agent process in a developer environment. The model is running here, and I can change this model. I can select
Uh,
a
Sparsh, actually, we are not able to see this, see that code. We can see only that. Let's see it in action.
sorry. Let me reshare my screen. Hope my screen is visible.
Yeah, wait, I will add. Yeah,
Okay.
perfect.
So let me restart again. So basically, um, this is a simple VS Code ID that I have, and I have installed a GitHub Copilot with it. So along with that, so the GitHub Copilot act as an agent for me, where I can interact with my code as well as the Playwright MCP that I have installed. So if you want to install Playwright MCP, or if you want to also browse different types of MCP, you can just go to the extensions page and you can find MCP servers down below. You can just uh, click, or you can click or view different types of MCP that are available with VS Code. And for this, I have just clicked on install Playwright, and this has been installed in my VS Code. You can also play around with different MCPs, and you can also check out the different capabilities of different MCPs. This can make your life very easier. So now what I have done is that Playwright MCP is installed. I have GitHub Copilot installed, and I have a VS Code ID. Now I can also select on different types of models that are available. So these are the models that come with GitHub Copilot. I can also add any premium model that I have an access to. I can select this. I can add the API key to VS Code, and I can enable this different types of models that are available. Now let's see what we have built to customize this AI agent that suits my needs. So basically, I have created three more files. These are chat modes, instructions, and prompts. So the prompt folder contains all the task specific prompts. So basically, I have different types of prompt that can basically start from automate form prompt. It can generate test cases, and it can also create a manual test report. It can also remove comments, etc., etc. Let's see what's in there. So these are simple set of instructions, like what is the process if this particular prompt is triggered, what it will follow. It will explore first. It will use Playwright's MCP tools to navigate and understand the websites, and then it will create me a structured TypeScript using Playwright test that for the scenario that we have given. And not only this, it will revalidate, it will execute and iterate till all the test cases that I have generated passes. And after that, we will also refine uh, the test that we can follow all the best testing practices that are out there. I have also listed down some critical requirements, that we have to take screenshots, we have to navigate different types of snapshots, we have to understand the application flow. So these are not generating test scripts blindly for a particular page. It is actually going into the page, iterating as a user, and then giving me all the scripts that I need. I have also added a success criteria. You can change the success criteria or any other overview or requirements according to your flow. And this will basically customize this agent according to what particular things that you need. Now, in the instructions folder, I have basically all the coding standards and the best practices that I need. So basically, if you have a particular set of themes that you follow in your organizations, or if you want to follow in your work, you can list them out there. That these are the particular locators I want to follow. These are the assertions or timeouts I don't want to follow. I can also define on the clarity. We can also define the test structure, the output of the test structure, that how it will import, how will describe all the hooks, all the titles. So the agent, while executing, have to follow these file structures, all the best practices that is there. So you have to iterate through, you have to play with this all the uh, instructions and context to get the best what you need for uh, your test script generation or whatever use case that you are building this AI agent for. So here also we have also added what a sample test scenario as well. So this is how I need my test generated to look like. I have also an execution strategy, also a checklist. I've also added Playwright documentation so that it can refer to all the locators, all the services that are there in Playwright as well. Now, chat modes. Chat mode is the most interesting part here. So, chat modes are basically AI personas or specialized mode. So, chat mode defines how AI should behave, such as tone, focus, or expertise. And like if you choose different chat modes, it should switch between different roles depending on the situation. So for example, I have a test explorer chat mode. What it will do is that it will systematically go through all the navigations, do a structure analysis of what are the pages, what are the buttons or the navigation elements that are available to me, and forms, input, delivery, key activities, uh, the documentation guidelines, the best practices. This is basically a test explorer persona. Similarly, I also have created a test generator persona. So what it will do is that it will go again, explore a page, it will plan, it will, and then implement a structured playwright test using playwright test, and it will execute test, it will refine them. And I've also set a key guidelines of what not to do. So uh, this is the must. I find it useful in the past that the website that we are testing should explore the page first. It should not go blindly and generate test cases. If you have used ChatGPT to generate test cases, you might have seen that it will give you a predefined what is supposed to be there on the page kind of a code in return. But what we need is here what is actually out there. I've also added some test quality standards. So let's trigger a different type of prompts. So basically, just homework for all of you guys. If you are a beginner or if you are exploring what is out there, I will share a couple of resources where you can just use this chart modes and instructions and prompts, and you can create your own AI agent which solves your needs. You can also use it for different languages or frameworks as well. So let's trigger this. Now the agent is saying that yes, we have triggered, but we have not shared the URL that we want to test. So let's put I want a systematic test for registration at LambdaTest.com. What we'll do is it will try to open a browser. Yeah. So it is asking me to that if it can open a browser or not. So what it did is basically it opened a browser. Now it is exploring the page. You can see the elements as there. Let's navigate to the registration page, and it found the registration page, and now it will write some test cases for this registration page. So also a disclaimer, again, still it's AI, so it might give you a bad result, but we also have to work with what AI has given as a result, and we have to correct if we can make any corrections in that code base, or if agent is, or we can also give prompts so that the agent can correct the test case that we require. So we have to be patient, we have to play with the context, we have to play with all the prompts that we are giving. So there is no exact prompt that solves everything, but we have to be patient about it. So again, it gave us a it gave us a couple of test scenarios. Now what we can do, so it can uh, so there are different types of scenarios. User can register with an email, homepage navigation elements, platform feature visibility, navigate to a browser testing section, integration sections, and it has given me a lot of test cases. I can go through this, and I can also execute this directly within the agent, with the agent as well. So this is giving me a run command. So I will just execute it and wait for the results. I'm pretty much seeing that it might give me a broken test, which I will have to then again go and fix, but that's completely okay. Yeah. So there are a couple of failed tests, so which we can solve or resolve. So as this is inbuilt with Playwright, this is a Playwright test report, and we can see what was the point of failure, uh, what is the screenshot out there. We can also view the video of this execution, and we can try to fix this test case and also push it towards it. So this is how we can build an AI agent or even customize agent according to your flow. So I will just quickly, due to interest of time, I will just quickly switch to the next slides. So this is basically what more you can do with an AI agent. You can create a server that helps you apply clean coding principles to all your previous code. You can give prompts like that. You can go through the test suite, refactor all the code, follow a clean coding practices, remove duplications that is there. You can add more stuff to it, and it will basically go through all your code and make some changes, give you suggestions, and you can accept it or reject it. So this has made our life a lot of like very easy, because this will take a lot of developers lot many days to apply clean coding principles to the passcode, and even developers don't even touch the code that is working. So uh, this helps us save time. So you can make a commit, you can fork it, and if it fails, you can go back to the previous commit as well. You can also make an agent that like similar to that, that if there is a new pull request that is open, based on the file changes, we only want to find the relevant test and run only those who which the new code has impacted. Or you can also triage test cases, triage test based on staging environment, and investigate the failures. And if it is a new UI change or any type of change, you can fix it, or you can also open an issue on your Slack team. So there is a lot of process that is made simpler using AI agents, and you can also try and have fun with this. And there are two couple of resources that I would like to share. This is one is basically Playwright MCP. So basically try this out. And uh, last one is basically a resource from GitHub. This is Awesome Copilot, and it has a lot of prompts, instructions, and chat modes that you can play with. So these are not specific to testing. You can also take a look at different types of chat modes, like if you want to address PR comments, if you want to uh, pull any type of comments, you want to push different type of changes, you can automate a lot of process that was manual earlier. That's about it. Thank you so much. If you have any questions, please do paste them in the chat.
So here's one questions like I picked Sparsh.
So Mahindra, so basically, yes, we can provide the context of application that is under test. So what, with the help of MCP, we are able to provide the context of our whole code base to that AI agent. So what the AI agent will do is it will iterate through all the code that is there. It will go to particular sections. It will see what kind of changes or suggestions that we need, and it will give you proper response. This was only possible due to MCP, when MCP came out, like to the world. How do you debug when Playwright action fails inside MCP? So it depends on specific cases. Like if playwright actions is failing inside FCP. So it depends on particular use cases. If you have any particular use cases when the actions are failing, can you explain a bit more to me? Or like
So
you can reach out to me on LinkedIn and we can have a chat around it.
yeah, so I will load next question.
How are you going to maintain test cases for enterprise applications which have a lot of workflows and other combinations? We need to reuse the code instead of starting steps from login page for every test cases. You do not need to start code from the start, like from login page of every test cases. So whatever code base that the enterprise applications have, they like a lot of enterprises have their own MCP models. So what the MCP model has done is that it has learned through all the code that is there. So it is on the same state as the application that you are testing, and like it will like whatever prompt that you give, if you want to build up, uh, you can use that particular prompt and it will try to maintain your test cases forward.
Thank you so much, Sparsh. And what I will do is like I will mark all the question to you. So as I said, like everyone, like we will dedicatedly like post each one question and give a detailed answer about that, and also like we will connect the speakers as well. Thank you so much, Sparsh, for the wonderful session.